This is Spot from Boston Dynamics at the recent ICRA 2025, one of the most attended events about robotics. Here we see the Robodog grabbing a blue box. His task is to put it on the top of the red box. And here is a Spot when he was a puppy 5 years ago, when he was presented at MODEX 2020, the main event addressing the logistic industry. Aside from the accessories on the top of his back, the movement of its legs and body hasn't changed much in 5 years, from MODEX 2020 to ICRA 2025. But if we switch the focus from Spot to the surroundings, here is what we notice. 5 years ago, Spot was remote controlled by an operator, as we can see in the picture. The Robodog was moving around as an operator controlled it with a sort of tablet, and cameras on Spot could show and map everything the Spot was seeing. When we saw Spot more recently, there was nobody controlling it. If we take a panoramic view, we don't see anybody manipulating Spot, and this was confirmed to us also by the people from Boston Dynamics at the show. Spot was performing a task by simply reading the instructions on this board on the floor. The transition from the joystick to the prompts took place in October 2023, when Boston Dynamics unveiled a proof of concept where Spot was equipped with ChatGPT and other AI models. This integration enabled Spot to understand natural language prompts, but also to make decisions based on the environment and respond with speech. We didn't hear Spot talking during ICRA 2025, but Boston Dynamics has videos in which Spot acts as a tour guide, describes the surroundings, answers questions, and even adopts various personalities, like a British butler or a Shakespearean actor. This is what they say at Boston Dynamics.
Plugging an amazing tool made by ChatGPT, or maybe OpenAI, ChatGPT, together with a robot. A very light layer of engineering. But what starts to emerge here is pretty cool, right? The idea of a future in which we're conversationally interacting with robots is coming.
All the Robodogs we saw at the show were remote controlled, and some didn't even move. The robots from Unitrees, for example, were also at the show, and they are probably the most used Robodogs for research due to their agility and affordability. They were also remote controlled on the show floor, but the research papers presented during the event featured Robodogs, including Unitrees dogs, equipped with AI, so we can assume that all Robodogs will get smarter in the near future. Here we also see Spot climbing steps without any problems, or go straight to his charging station when he needs to rest or recharge. These movements seem very simple, but they are the result of a constant testing, data collection, and perfect integration between software and hardware. You don't have to take our word for it. Just listen to what Aaron Saunders, CTO of Boston Dynamics, said at one of the recent NVIDIA GTC conferences.
Test, 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 right? You can run an almost unlimited number of simulations, and then you can follow it up with some amount of physical world testing, and the only thing that limits you is the amount of hours that you can get on a robot. This is a little video of a test lane. This is one of the areas that we test our products. Our quadrupeds in the building, our test fleet, operate 24/7. They travel about 2,000 hours of locomotion or 2,000 hours of tasks, whatever they might be, a week. They do it in thermal chambers, they do it up and down stairs, we replicate pieces of our customer site. There are ones that walk outside in the rain and the snow, there's ones that walk inside on carpet and static. And this is really about robust hardware-in-the-loop testing. So the Spot robot fleet has cumulatively walked 250,000 kilometers. Right now, it's aggregating one circumference of the globe every 3 months. So the fleet is walking about that far every 3 months.
When we saw Spot for the first time, there were a few hundreds units around the world. Today, they are 2,000, and the demand is increasing as new business and new sectors discover the potential for a robot with these capabilities. This means that Boston Dynamics has to make sure that the robot doesn't fail, which in dog robot language means it doesn't fall. In the last 5 years, Spot's balance has improved dramatically. Take a listen.
When we started at 2.0, the level of falls were about 0.6 falls for every kilometer of walking. At the time, this was okay. There was no other product like this on the planet, so that was an acceptable place to be. But as we got into industrial sites and we started working with our customers, a falling robot, even if a robot can get up, is not a good robot for a customer. So even though Spot can get up and recover from almost every fall it takes, it's still not a good idea for the robot to fall because customers will perceive that fall as a problem, or it could be a legitimate hazard, or it could break the robot. So we work really hard in driving that number down. So over the software releases, you'll see a consistent improvement. This is a combination of making improvements in our hardware, in our software systems, but right down around the 3.3, we got to about 1 fall in every 50 kilometers. So Spot can walk about 50 kilometers now for a typical customer and only fall once. 20 years ago, these things didn't exist. And 5 years ago, none of these things were in the real world. So getting to 1 fall in 50 kilometers is a big feat. The teams worked really hard about that. And we still want to take that further, of course.
So what is the future ahead for Spot? Speech seems to be the next frontier, but let's hear from Boston Dynamics what they are working on.
Performance is something that we've always leaned on. I think there's a lot of different takes on how important it is for a robot to have performance. For us, performance unlocks ability to really explore untapped potential, right? So whether you're building a robot that can walk in highly unstructured outdoor terrain, or whether you're building a robot that's manipulating things, you don't want to be limited by the machine. You want to be able to explore the capabilities of that machine's kinematics, of the potential of those applications. So we really want to make sure that we build performant machines. Recently, with the backing of our Hyundai, we've really got into vertical integration. This lets us speed up development cycles, so we're able to manufacture our robots, we're able to change them quickly, and that's a key in moving quickly, because these robots are far from being done. We've got new machines out in the world in new industries, and we need to be able to keep up with the changes. On the software side, most of what we do is vision-driven autonomy, so we're looking at the world around us, we're understanding the environment, we're understanding context for that environment so that we can understand how we want to interact with it. Reinforcement learning, I think we're going to talk about a lot today. This is kind of an emerging capability for the industry when it comes to, at least when it comes to product. And then lastly, we're commercializing. And I think this is really one of the very central secret sauce things for Boston Dynamics. When you have a commercial mission, it provides focus. It's where we're finding intersections that weren't there before. So you could talk to machines before, you could talk to your cell phone, you could talk to robots, but starting to merge together characters, starting to merge together different languages and how you interact with machines is a pretty exciting thing.